Hello and welcome to the homework help video for the semester 2 final prep thing. This says semester 2 final exam. This is not the final exam. I just brain farted when I was making the title. That's okay. So we're going to get right into things. It's kind of late for me when I'm recording this, so I'm just going to get right into it. Simplify this expression. This is classic just order of operations. I will tell you, this is more for practice than it is for the actual final, because this is something you can plug directly into your calculator, and that's not what I want to test you on. That being said, the correct order is, well, 8 minus 4 is 4, 4 plus 2 is 6. Of course, I do those ones first because they are in parentheses. Parentheses mean to multiply, but there is nothing to multiply. So, therefore, once I'm out of operations, I can just get rid of them. And 1 minus 6 is negative 5. Number 2 is asking about kind of representations of numbers, and we can represent numbers on the number line. That's what it's called. And we start at 0. So you have to start at 0, and the one that starts at 0 is negative 11. That leaves us with B. That's the only one that has negative 11 first. Yeah, negative 11 plus 7. That does show, by the way, why you have to subtract when you have two things of opposite signs, and also why the one with the bigger absolute value, why it wins. Yeah, the answer is negative, because you have to go further to the left than you do to the right. That means you're going to end up on the left side of where you started, of 0. So, cool. Anyways, that's number 2. Number 3. Number 3 is interesting because it asks about, do you understand what is happening from step to step? And that's the key. If I include questions like this, let me rephrase. I will include questions like this, and it's up to you to figure out what's going on here. And you really got to look from this step to that step. What happened? Well, we got rid of parentheses. Was that done correctly? We have to ask ourselves these questions. Well, to square something means to multiply it by itself. So that 2x all in parentheses squared means 2x times 2x. And that should be 4x squared with no parentheses. And that's not 4x squared, that's 2x squared. So that's where the mistake happened. Step 1 was not done correctly, as opposed to going from step 1 to step 2, where she distributed the negative. Negative and 3 turned into negative 3. Negative and negative 2 turned into positive 2. That's correct. Did they combine like terms correctly? Absolutely. This is x squared and that's x. Those do not combine. And both of those don't combine with 2 or 5, but 2 and 5 combine with each other because those are both constants. So yes, combining like terms was done correctly. It was step 1 and only step 1 that was done incorrectly. Number 4, I expect you to know certain words like evaluate. Evaluate means plug in. It says x equals negative 3. Sure, let's plug in negative 3 for this x and for that x. And don't tell me that's 2 minus 3. It's 2 times negative 3. 2x means 2 times x. So it's 2 times negative 3. And follow the steps. Negative 3 minus 1 is negative 4. Negative times a negative is a positive. 2 times negative 3 is negative 6. Negative 6 minus 8 is negative 14. 1 half times negative 14, half of 14, that's negative 7. And sure, 4 plus negative 7, that's 4 minus 7, that's negative 3. Number 5, we talked about in class, in both classes. But yeah, sure, it's a planter, it's a rectangle, particularly the perimeter, length plus width plus length plus width, otherwise known as 2 lengths and 2 widths. All that they tell us is that the longer side, it's 5 inches more than the width. So we can say that plus 5 and plus 5 there, but plus 5 compared to what? We don't know. And that's where the x's come from. I don't know the width, so I put an x. X plus 5, x plus 5. We add those all together. There's 4 x's there. And there's 2 of these plus 5. That makes plus 10. That's why I get C as my answer. Number 6, I had a lot of questions about because folks were like, well, what do you mean? You distribute the negative and that's this one here. They didn't distribute correctly, though. Yeah, but that's not the only first step that you could do. The other first step is you could divide to cancel that negative. That's a coefficient of negative 1. You divide to cancel coefficients. So if I cancel that negative and then the other side I divide by negative 1, hey, look, it works. A is the correct answer. Number 7, this is an inequality. Oh yeah, we got to know our inequality rules. Things like if you divide by a negative or multiply by a negative, you have to switch the direction of the inequality. If you divide by a positive, you don't have to do that. It's only by a negative. So I add 1 to both sides because that doesn't matter, and that does not switch the sign of inequalities. Then I divide both sides by -3. Again, it's going to be very, very easy to say add 3. That looks like a -3, but it's not. It's a -3 times x. So I divide by that -3, switching the sign of the inequality, and 21 divided by -3 is -7. Cool. If I'm not mistaken, I can, yep, there we go. There's page 2 ready to go. I'm so good. And we get to solve this equation. Sure, this is an absolute value. Doesn't matter. We treat them like parentheses until we get to this step here. But first, we can't access the things inside the parentheses. So I'm going to divide by 2 to cancel that 2. Again, typically you can distribute into absolute values. It's just dangerous to do so because if you distribute a negative in there, it actually does break things. You don't want to do that. So typically I'll just say just don't use the distributive property with absolute value just to be safe, So normally when you get rid of the multiplication, it gets rid of the parentheses, but absolute value are parentheses and they are also their own operation. So the only way to really get rid of them is to split up the equation into 2. And one of them is going to end up with a negative and one's positive because again, 3x minus 4 is just a number. And it's when that number is 7 or when that number is -7 that the absolute value ends up with 7. So cool, I split it up into 2, add 4, divide by 3, and these are the answers that I found. Number 9, once again we are asked to solve this absolute value thing, this time in inequality. I kind of cheated because I knew the answer was D, so I started with answer D. You might start with A, B, C, and then get all the way to D. You have to do like all of them before you get the right answer. Kind of annoying, but that's okay. And yeah, sure, we're going to divide, we're going to split it up. Again, the thing to note about this one, I'm not even sure I'm going to put this in the final, but maybe I will. When you split up an absolute value inequality, when you switch the sign of the number, you also have to switch the sign of the inequality, the direction of the inequality, I should say. And we add 1 to both sides. We end up with -7 plus 1 is -6. 7 plus 1 is 8. So those are the ones that I'm looking for. And yeah, those are in the correct order as well. Our left-hand inequality is greater than. Our right-hand inequality is less than. Cool. Number 10, I'm actually skipping. I feel like it's written in a kind of intentionally confusing way. If you're wondering, the answer is B, by the way. Yeah, 60 minutes. It takes her 4 minutes to get ready. That's 4 minutes that she spends just one time. And then it's 14 pages times however many minutes it takes her to read a page, right? So that's the answer, but I just felt like it was a little intentionally confusing. Number 11 asks, we have a function relating the input x, which is the number of hot dogs. It tells you x is the number of hot dogs. Look how many times I'm putting this out. R of x, that's the number of hot dogs. 203, that's where x goes. That's the number of hot dogs. So our answer is B. 203 is the number of hot dogs. It might be tempting to say C, but no, let's not overthink it. It's just you sell 203 hot dogs, you get $812. That's it. So done. Number 12, plug in -7 for x. This is not an arrow, by the way. This is plug in -7. Sure. So f of -7 equals -1/4 times -7 minus 9, all plus 1. -7 minus 9 is -16. Negative times negative is a positive. Again, to multiply fractions and whole numbers, you treat it as if it was 16 over 1, and you multiply across. 1 times 16 is 16. 4 times 1 is 4. 16 over 4 is 4. That's 16 divided by 4. And then 4 plus 1 is 5. So that's our answer. Number 12 is A. Number 13, we need to select the real world situation that could be represented. And so I think the easiest way is just list out some points. Be careful. This one's counting by 2, so I didn't include this in between because I'm like, yeah, that's 1, 12, 2, 16. The next one would be 3, 20, yada, yada. And we're adding 4. It's plus 4 each time. Well, that's saving $4 each day. There you go. It's like always this plus 4, and that's each day per each. These words mean that it's something you're doing repeatedly. Cool. Moving on, number 14. This one's asking about common ratio or common difference. This one is a common difference. Common ratio is something that we mentioned. It's when you're multiplying repeatedly. This is when you're adding. That's a common difference. And I actually chose to rewrite that 1 as 3 divided by 3 so we can more easily see that this is minus 2/3, minus 2/3. And that's why the common difference is negative 2/3. Number 15, I'm subtracting 9 apparently repeatedly. At least it happened twice. I guess we're left to assume that it keeps happening. And I'm like, all right, well, another name for repeated addition, or in this case, subtraction, is multiplication. So I am multiplying by negative 9, and this is the only one that does that. As for the rest of it, at plus 16, because, our first number is 16, our initial value. And if you're wondering about the n minus 1, it's because you don't have to subtract 9 to get the first number. And that's why it's n minus 1. If I want the third number, I only have to subtract 9 twice. So that's why it's minus 1 from, anyways. Number 16, all we need is a couple points. So I listed out some points, and then I used the slope formula. And here's some points, 0, 20, and 1, 25. So I called this one 0.2 and this one 0.1. It really doesn't matter. You could have switched the numbers around. You would have ended up with negative 5 over negative 1, which is still positive 5. And that's our answer, D. Cool. Number 17. Points are x, y. Christoph plugged in 4 for y and not for x. Right, and there's y. There's y. That should be a negative 1. Substituted incorrectly. Lots of folks do it. No big deal. All right, next one is this. We're moving right along. Number 18 asks to select the ordered pair that is the solution to the system of linear equations. A solution to a system of linear equations is just where they meet. There's lots of ways that we can solve this. If it's on a graph, you can just point to it like there. That's the place where they meet. If you know what a solution is, you're like, oh, okay, well, it's something that's true when you plug in these values for both. So I could plug in 2 for x and negative 4 for y in both equations, and I could show that you get a true statement in both. I would end up in the first equation with negative 16 equals negative 16. That's a true statement. In the second equation, I would end up with 16 equals 16. That's also a true statement. So the fact that I got true for both of them is what tells me that this is the correct answer. That being said, here's another way. I like to solve this type of problem using the elimination method. And in that method, we try to add or subtract things in like whole equations together so that something cancels. And this one requires a little bit of setup. I have to multiply the second equation by 2 to get 4x minus 6y. But then when I add both equations together, the 6y and the negative 6y, they cancel. This is called the additive inverse property. And then as for everything else, 4x and 4x, those don't cancel because, again, I'm adding. I get 8x. That was a problem that I saw way back when we were doing this unit. People would say 4x plus 4x cancels. And I'm like, no, it doesn't. Negative 16 plus 32 is 16. Divide both sides by 8 to get 2 is our answer for x, which I actually could have stopped there since this was multiple choice, but your test won't be multiple choice, and so I went ahead and plugged in 2 for x, because this is how you would continue it. You'd be like, all right, well, I know x, classic math problem. I know one number, let me plug it in and find out the other one. So I plugged in x, the x value. 4 times 2 is 8. Subtract both sides by 8. And then, divide both sides by 6. I end up with negative 4. Very easy to forget negatives on this type of problem, so just watch out for that type of thing. Number 19, this is from our most recent unit, and this is, mean and median, right? So it's already lined up for us. To find the mean, we just add everything, divide by 10. So I got 228. And then I divided that by 10 to get 22.8. So cool. The median is just the number in the middle. And in the middle here, we have 21 and 25. Add those together, divide by 2. You end up with 46 over 2, and that's 23. So that's where I get the median for A. For B, again, just add them all together, divide, you get 25.9. And the median, what's between 26 and 26? Yeah, it's 26. So you could do 26 plus 26 divided by 2. You will get 26 though, I promise. Okay, moving on. Number 20. Again, 10 more numbers. In fact, that's right, it's the same 10 numbers. By the way, that means B has a bigger number for both the mean, 25.9 as compared to 22.8, and the median, 26 compared to 23. Number 20, it asks you to find the range and the IQR. The range is the easiest, just the biggest number minus the smallest. So the first one, 31 minus 16, is 15. The second one, 30 minus 18, is 12. So the first set of data has a higher range. The IQR, the interquartile range, is basically do the same process, but only use the quartiles, which is to say, just kind of like this middle part of the data. We exclude the things on the outsides. So cool, 28 minus 25, oh wait, what are you doing? 26 minus 17, that's A, and that's 9. And then 28 minus 25, that's only 3. So number 20, class B has a very small interquartile range. And once again, we see one of these classes has a higher value for both, and that is class A this time. Okay, number 21 through 23, at least on this page, is these are all quadratic things, changing forms. So we are changing factored form into standard form. And it doesn't specifically say change it into standard form. It doesn't say to use the box method, but it does say to simplify. And if you know you have to do something, the only thing you really can do with factored form is box method, so that's what I did. 2x minus 3 times 3x plus 5. So I get 6x squared, a negative 9x, and a 10x, which is a positive x. Be careful because there's a negative x over here, very tempting. And then negative 3 plus 5, negative 3 times positive 5 is negative 15. So yep, everything checks out for C. Number 22, we're supposed to factor this. So once again, I can use the box method. When we're factoring, again, this is not completing the square. When we're factoring, we put the constant in the bottom right corner because I'm not trying to change the constant. I'm trying to factor it exactly as it is, rather than trying to turn it into what I want, like we do in completing the square. So, yeah, I get a positive 9 and a negative 9. There are other things that you can multiply to get negative 81, negative 27, and 3, for instance. But the reason I chose these is because negative 9x and positive 9x cancel out entirely, and that's why this one only has 2 terms, whereas number 23 has 3 terms. So that is C. Number 3, we are factoring once again, and therefore we put the constant in that bottom right-hand corner, and I'm trying to get 2 boxes, bottom left and top right, that give me 1x. And this is the combination that I found, positive 4 and negative 3. Again, you might need to search a while. Notice I have it white out. I actually chose wrong first, and I was tired, I guess. So sue me. I can't remember what I chose, probably 6 and 2 or something. I don't know. And so don't get discouraged if your first guess doesn't work, right? So yeah, 4x minus 3x is that positive x that I was looking for, because that's what we have. And so everything's accounted for, and that means x plus 4 and x minus 3, those are the factors. And I believe that brings us to our final page here. Yeah, there we go. Whoa, that was weird. The domain and range of this graph here, sure. And domain is just possible x values, but again, the way to think about it is what's the smallest x value and the biggest x value you can get. Well, this one has arrows going in either direction, because even though this arrow is going almost straight up, it's not straight up. It is a little bit to the left, and as long as it keeps going just a little bit to the left, we can say, well, it's going off to negative infinity on the left-hand side. Same on the right, positive infinity. So sure, the domain is negative infinity to positive infinity. Right away, I know that's the only one that could be the answer. So it's A. But once again, your test won't be multiple choice. What about the range? Well, both arrows are pointing up, and that's positive infinity, but it's not positive infinity to positive infinity. No, that's silly, because it's the smallest y value. Those are both biggest y values. The smallest y value is way down here. This is 1 comma -9. So -9, that's the smallest y value, and that's why our range is -9 to infinity. Sweet. Number 25. We want to take this graph, 2x squared, and we want to shift it right. Well, moving left and right, that's the job of h. H always does things opposite of what you would expect, and so therefore, we're going to go ahead and say that h is not positive, it's negative, and so h goes inside parentheses, and that's this guy right here, x minus 6. Cool. All right, number 26. Find the zeros. There's lots of names for zeros, intercepts, solutions, there's tons of names that are fairly interchangeable. And basically, we just need to solve this thing. And we plug into the quadratic formula to do so. It's not the only way you could do it, but it's probably the best way for this particular problem. And I get a negative of -5. I get positive 5. -5 squared, that's 25. -4 from the formula times 4 times -6. Be very careful with your negatives. -4 and -6 multiply to get a positive. Multiply it all together, you get 96. 25 plus 96 is 121, which when you square root, you get 11. And so I get all these answers. I get way down here, I get the answers -3/4 and 2. Those are not the answers, however. I didn't circle this 2 because of that 2. I circled that 2 because there are 2 answers. That's what it's actually asking. How many answers are there? And there are 2 of them. Because it's possible to only have 1. If you have the square root of 0 in there, then it's just 1. If you have the square root of a negative, that's when you have no answers, because you can't square root a negative, so be careful of that. D was never going to be an option. You cannot get 3 answers with a quadratic. You can only get 0, 1, or 2. Number 27, we're almost there, asks us to put this in, to state the zeros. So again, I could use the quadratic formula, say A is 1, B is 2, C is -8. But I was like, you know what? I'm going to do this a different way. I'm going to factor this. And just what happens, this factors to be x plus 4 times x minus 2. And since this is factored, I can set each piece equal to zeros. Again, that's why they're called zeros. And subtract 4, I get x equals -4. And I get x equals positive 2 for the other one when I add 2 to both sides. And that's why I get A. Number 28. This one I should have caught earlier. Yeah, the way we learned it is we were doing this process and turning this into this decimal version. This is a, shall we say, more exact version of the answer, and we get that through the simplification of this square root thing here. Fairly complicated process, kind of annoying, and no big deal. As long as we understand the idea that we have 2 answers and we can find them, and there they are. And we could take -3 plus the square root of 6, and we would get this answer here. And we could take -3 minus the square root of 6, and we would get that answer there. And that's how we show that they're the same. Cool. And yeah, number 29 brings us to the last but not least. And of course, we had to save the best for last. We have completing the square. So we need to find the vertex form of this because we want the vertex of the quadratic. And in order to complete the square, typically we'll move everything onto the, we'll move the constant away so that we have like a blank slate. We have a +0. We're like, all right, well, this is x squared plus 6x. That's an x times an x to get the x squared. That's a 3x and a 3x to get the 6x. That gives us x plus 3 and x plus 3, 2 of the same thing. But the whole thing is, if I want it to be x plus 3 times x plus 3, I need a +9, which I didn't have. because I moved everything over to the left, or the constant at least. So I just add 9 to both sides. Now I got a 9. It's just about making it the number you want it to be. That's what I love about the completing the square process. Now that it's what I want it to be, all this stuff in the middle here, I call it x plus 3 squared. And I finally end by subtracting that constant, putting it back onto the right-hand side and saying, all right, well, h is opposite, k is the same, and so that's -3, -17. That's the vertex. And my friends, that is the entire practice test. The only thing that I would say is that, again, remember, this is just a sampling of like what we did this year. It's not supposed to be every single topic. So some things that were not on the practice test but could still absolutely be on the final, things like, graphing linear things. I didn't ask you to actually graph a linear equation, but you should be able to, both in point-slope form and slope-intercept form. You should be able to convert a linear standard form into one of those other forms, right? So, like I said, sampling, but not everything. All right, so keep that in mind and go back over your notes from all the units. There will be more things from semester 2, but there will still be a couple of things from semester 1, especially solving equations and especially graphing. So keep that in mind. All right, and that means for the last time this year, I hope that was helpful, and I will see you again. No, I won't. That was the last time. I just said it. So I'll just say bye-bye.